You started recording? Yeah, perfect. Yeah, let's get started. Yeah.
Okay. 1 second. Let me. Here we are on week number 7. Wow, just time flew by. It's been. I totally enjoy the whole all the sessions that we're doing. So this is the 7th week. Last week, the topic is huge from Azure storage perspective. So we covered couple of key areas on the storage system, or the Azure storage specifically. So we have finished the rest of the portions. So I just want to quickly touch base. So these are the next sessions, which is going to be, I need to change the decks here a little bit. These are the additional sessions we are planning to do in our databases, marketplace, big data, and our AI as well. So it's a continuation of the Azure basic services. In total, 15 weeks would be there. Next, I would say another 6 to 7 sessions will be on the end of it. But yeah, so let me quickly touch base on what we covered last week. So the topic is about the Azure storage services. So especially in the cloud scenario, one of the most widely used service we have is the storage systems, because that's where you keep all the data. That's where you keep all your content, be it databases, blob storage, pictures, and no matter what, that's where you store it. So again, the traditional way of storing things, I would say disks in your on-premises scenario. You might have a bit of bits and pieces of blob storage as well, depending on the storage system you use. On the cloud, there are different types of storage systems. It could be a disk, which is a physical storage disk that you have, and you have files. Files meaning a single a file server would be available to be shared by multiple different systems and servers and things like that. And we have objects. This is one of the widely known storage system in the cloud is objects. If you take Azure, it's blob storage. In Amazon S3, Google has got its own type of storage system, which is equivalent of that. And also the last one is tables and queues. So think about tables as like it's a NoSQL store. It's not a database, but it's got the same characteristics of a NoSQL database like Mongo and Cassandra, but it is purpose built for certain use cases. And the last one is queues. The queue is basically a sequential processing of first in first out methodology. So these are the different types of storage systems we spoke about. And I think one other thing which I want to really stress, the point is it's durability. Durability means your ability to retrieve the data on demand when you want it and whatever time you want. Doesn't matter what it is. You have a consistency in able to get it out. And encryption, at the very core, the basics, encryption at rest is a must-have feature. So in Azure, we have SHA 256 type AES 256 advanced encryption system mechanism to store. By default, you cannot switch it off. And also replication, right? Consistent replication, meaning is Azure is made up of multiple, or any cloud system or public cloud is made up of multiple different, we call them availability zones, or we call them availability regions, able to replicate the data into the secondary region is must have. So Azure does that as by default. That's one of the core engineering capabilities we have built from ground up. And fault tolerance. Something goes wrong in a server, right? For example, if a storage cluster goes down, will that affect your availability of data? Yes. But even in the circumstances, we should be able to give the data for you. So that's what we call as fault tolerance. And auto load balancing, right? Because, for example, you have seen the traditional way where a particular disk is being overused constantly because every single thing is stored on it. And how do you load balance your incoming request into different sections of the data? For example, that's where the caching comes into play. So I think encompassing the types of storage systems are very key. And also not only that, offering different types of storage systems is not the entire story. The story is able to for customers to consistently access the data and give them the access with the security, with the compliance, and able to performance needs also very important. That's a fault tolerance as well as load balancing comes into play. So we looked at multiple use cases where the durability comes in. I'm going to quickly skip over to the section we're going to talk today. As always, if you have questions, feel free to jump, ask me stuff. So I need to present again. Okay. So today we're going to see one of the key pillars. We looked at durability, security, compliance, manageability, cost efficiency, scalability, and performance. And the last one I see today is the opening interoperability. So today I have a couple of. So today what I'll do is Kader and team, I'll finish this section today, and then next section I will talk about databases, because database by itself is a huge topic. I really don't want to split them into two chunks because there are continuity pieces, it's a long session too. So I'll fully focus on the data, go deep, and then once we finish it, we call it a day for today if it's okay. And then next week we'll focus purely on databases as well.
Sure. Perfect.
Let's go into it. Yeah. Okay. So see, providing you a massively resilient database with a different offering like disks and file systems and blob storage and queues and a NoSQL type tables is all fantastic. But how do you access it? How do you interface with it? So that's where the core. You might be building a Go application. You might be building a Java. You might be building .NET. You might be doing Python. And you would be, most of your customers would be residing only on mobile phones, like something like Instagram, where you always interact with your device using interact with your application or device. There might be certain scenarios where you have customers across the world. They might hear different ways of accessing them. One team would be writing only on Java. One team would be writing on Python. What do you do? So in that case, that's where the engineering aspects of interoperability comes into play. So for example, today we have multiple different APIs and blob storage. All Microsoft services are basically REST enabled by default. REST is available. And we also provide you tools like AZ copy and CLI and PowerShell, the whole multitude of tools as well. And also with mobile programming, we also offer multiple ways of accessing the storage systems using Xamarin, using SDK that are specifically built for mobile. So from one thing is the infrastructure piece, and the second one is automation and coding and things like that. So that's the interface is available for customers to use it with any way, shape, or form they want to use it and access it. So one of the use cases you always find is ReadTree and Resume, retry and resume. So all the APIs have similar nomenclature in terms of, for example, if you're trying to pull up a data, and then if there is particular the rack or storage system is not available, what Azure do is it will send you appropriate numbers, for like specific error messages. But at the same time, what it'll also do is if you retry the same download after a few seconds, it'll make it work. So there's a retry. It's one of the things that you learn on the cloud world is the ability to provide these sort of ability, retry and resume, parallel uploads and parallel downloads. For example, if you have, let's say, hundreds of terabytes of data, right? In the traditional way, if you keep just copying chunk by chunk only on a single process, you'll never be able to get the download the entire file because it's going to take longer. That's why the parallel streams of inputs it's able to write and extract is key. And if you go to AZ copy, you can actually spin out, I want 15 threads. So that what happens is these 15 threads all go and hit the same storage system and then download the data. So if we talked about load balancer earlier, right? So what happens when you are having 15 threads hitting the same storage system? What happens internally? all the requests are channeled into a massive load balancer, and the load balancer goes and picks up data from the appropriate segment of the storage system, and then picks it up. As I spoke to you earlier on the time, I think I spoke earlier on the topic, is where when you have a single set of data, it's split into 3 smaller chunks and stored across a data center. So that gives you ability to retrieve and also durability out of the box. So these parallel streams of input extraction and writing into the storage is also very key. At this point in time, the IOPS on a blob storage can go up to 80,000 IOPS per second, including parallelization. So let's go into a new type of storage system. It's called the Azure Data Lake Storage Generation 2. So the whole idea of ADLS Gen 2 came about when a lot of the the traditional blob storage system that you see, right? It's like it has got a way of working on its own. It is fantastic. It was really good, but most of the net new customers are basically looking into new ways of storing. Like they had Hadoop systems on premises. When you have a Hadoop, it had a very unique way of writing and reading from the storage system, right? So what we did is we wanted to have 2 types of system. One is we converged the traditional Azure blob storage, and we had a product which is called Azure Data Lake Storage Generation 1. The Generation 1 was basically the first iteration of our blob storage, where what we wanted to do is we build a Hadoop compatible data lake repository. So why we did that is, if you're having Cloudera, if you're having Hortonworks, if you're having any type of Hadoop compatible storage requirement, you can use the Azure Data Lake Store Gen 1. But at the same time, what happened also with that is there are some challenges which came with it, because Hadoop the storage system has to be purpose built, has to be stored on certain different type of clusters. It has to have by a certain hardware. But from a scalability perspective, it was challenging. What we did end up doing is we merged the API layer from the ADLS Gen 1 and merged that with the ADLS with the Azure Blob Storage. All of a sudden, the magic happened is where we have still the Azure Blob in the backend, but the APIs that you use to interact with it also basically it's like the Hadoop compatible APIs. At the same time, what also it gave you is a massive performance and scale and availability, because blob storage is built with that. If you think about it, it also brought in a couple of key capabilities because it used the blob storage. First is the semantics, the directory, the file level security controls, and the tiered storage. I think I did speak about the tiered storage model, where we have hot, cold, and archive. So all the capabilities came into it. So the use case for this particular ADLS Gen 2 is predominantly on the big data loads, big data workloads. So the big data workloads tend to have petabyte scale, which means the systems are supposed to be built able to handle petabyte scale of data. At the same time, it also need to support traditional things like hierarchical namespace. So where the files are organized to if you go to your C drive, there's C drive has got like a directories underneath that. It also need to address that. And also one of the things we also expected to have is performance. So if you want to have a large petabyte scale of data, then it has to also have all the performance needs of that application question. Let's say if you're running, give an example, a large file like movie library as an example, or if you're running a massive store where you're keeping all your product information on the blob storage, and you're having a gazillion entry points for your autonomous car and connected car scenarios. In that case, if you still need to have able to store a lot, but you still need to have the simplest of the way to access it. At the same time, performance has to be higher too. Security, on a lot of the these ADLS Gen 2 also supports a POSIX type security model, which also gives you one major advantage, where if you're building any Hadoop-based system, POSIX can be used. So in summary, this blob ADLS Gen 2 is a new generation type of storage system, which is compatible with your Hadoop file system, as well as you can also use the similar functionality as of a blob storage. That's why we have this protocol, a multi-access protocol, which means you can use the same API that can behave and change itself based on the type of use case you're dealing with. And we also build customized drivers that are built to for optimization and performance as well. So long story short, it also from a cost perspective, we're able to give lower cost of ownership because it's built on blob storage. If you look at the life cycle, the three key aspects you want to take from ADLS Gen 2 is object tiering and life cycle policy management, which means able to move from hot cold to archive, active directory integration, and RBAC role-based access control, right? So every time you create a storage account, it can automatically attach to an active directory, which means all the privileges and policies that you define on your AD, and then that gets dropped into the role-based access control and can be applied, which also means less overhead on maintenance on access control. The last one is HADR support. So what are the challenges we had on the generation 1 type ADLS is from a HA and DR perspective, there has been few challenges, but some data centers didn't have all the hardware necessary. But with ADLS Gen 2, everything is in use blob storage. Blob storage has been Azure for last 12 years now. So all we did is we built an API layer on top of it to make it highly available. So we talked about the multi-access protocol. I think there's automatic thing set up. The multi-access protocol is basically if you have a blob endpoint or a ADF endpoint, DF endpoint, it basically uses the same. I need to cut the automation there. So what happened with that is a single API you can store the data, but what you can also do is using different types of APIs that you can manage and extract the file systems without you need to go about and managing all the different types of configurations and things like that. Where it is useful is there are use cases where you might want to store the data in one format and then you want to extract it using another format. You can do that today at this point in. And the last one which I mentioned is the file data store, right? So which is the network file system where this is like a traditional files where you have like a particular storage as we shared with multiple different servers. This is where the NFS comes into play there. And one of the key things that you will notice within Azure is we work extensively with vendors like NetApp file systems. Actually, NetApp file system is getting very, very interesting. They're buying off quite an interesting number of companies that are in the storage area. So one feature I like today within Azure is called the Azure NetApp files. So it's basically what NetApp has did is they took all their key file engineering aspects of it, and they built a brand new product on Azure, which basically, if you think about what they did is they took all the hardware, software, all the engineering aspects of it and deployed that as part of the Azure Fabric level thing. And the NFS, the Azure NetApp files, behaves and acts like an Azure native service, like any other service, like a first-party service, but underlying it uses the Azure NetApp's own technology. So if you're wondering where this makes sense, on two ways it makes sense for a lot of customers. As a customer, you don't need to have separate contractual agreement with NetApp for you to consume this particular storage system. And also from a scale and availability perspective, because they're building their own solution on top of Azure, they can give you very unique capabilities which is not natively available within Azure. For example, you can reserve capacities with certain number of IOPS, with exceptional number of IOPS. Some of the things they talk about 100,000 IOPS for a shared file system, right? And also they have instantaneous replication where you can have additional controls over it. Where do you think this use case is? I've seen this particular NetApp files are used if you're having a large Citrix environment where your user profiles are stored on the local drive. And every time, let's say, assuming that this Citrix is hosted on Azure, you have 5,000, 6,000 users. Most of the Citrix are basically, they don't store anything. They tend to store on a small C drive for the profiles. In this scenario, NetApp can be used and attach that the virtual machine, the Citrix VDIs to the NetApp file So anytime a user logs in, the request to get the profile goes to the NetApp files and instantly brings it up. So the NetApp is opening up use cases which is not unknown before, in my view. For example, if you're running Azure Kubernetes service, if you, in order for you to share state, or if you want to share any configuration across multiple nodes, you can use the Azure NetApp files. I definitely recommend you guys to have a look at it. It's one of the best engineering effort in terms of connecting Azure and NetApp. It's in terms of performance, in terms of scale, the role-based access control. It's one, they've done a fantastic job. There's a lot of content on the YouTube. I would definitely recommend you guys to go and take a look at it. Here comes the big box thing. So where again, Microsoft is we call as a hybrid vendor. So where we still work massively on on-premises, and customers' data centers, private cloud. At the same time, we also offer a lot of services within Azure itself. So one of the key challenges, just one second. One of the key challenges which have been happening in the past few years is ability for customers to move massive volume of data. So where I've seen customers have petabytes of scale. So using the data box, they can actually move the data from on-premises into Azure at a high velocity, high speed. And there are multiple different types of data boxes available, starting from petabyte scale to terabyte scale. So that's one of the new innovations we have seen it. So yeah. So next one I want to go into is the serverless. I think we spoke about last week about briefly touch base on the serverless set of things. So in terms of serverless, when you talk about serverless, the first fundamental fact of the matter is ability to trigger an event of some sort. When the event gets triggered, you go and do an activity. So why this is important is for a very simple reason. Last week I showed a sample where you're having a photo sharing website, and users would host photos or log photos or like store the pictures, and you don't know when they're going to do it, right? Because you can't really predict when, if you have 100 million users, you don't know when even if you're 10 users, you don't know when they're going to do it. So this is where what we've done is we've taken that storage blob and we injected a specific piece. It's called event triggers. So whenever you open a file, if you touch your blob storage and you just store something, immediately it will start to send a trigger. So what we do is the trigger, we capture it in a system called event triggers. So, and when the event trigger happens, you can do some interesting things like, hey, when somebody is hosting or storing a picture or uploading a picture, immediately send me notification that do some processing. You need to do some compression of the pictures, or you might need to do some modifications on that, or change the file names and things like that, using this event trigger model, the serverless compute model, where a blob storage can be attached to multiple different event processing capabilities, and that can be that can be attached to Azure function or logic app to do some processing. Where this is useful is on the net, a lot of new use cases that are coming up constantly on this particular scenario. So last week, I think Kadir was asking the serverless and all the things in. So this is one area I really want to stress out is the event trigger model is baked into the Azure storage, and not only Azure storage, every single service in Azure has got an event trigger model. For example, if somebody queries a computer or queries a virtual machine, somebody pokes into a virtual IP, somebody pings an IP. So every time something happens on the particular resource, we have an event trigger model. That model basically watches for the events constantly. When the event comes in, and it will give you an API endpoint, and then using the endpoint, it will trigger additional downstream workloads or activities, or using functionless and things like that. It's a very key concept. Especially on the blob storage, where it can be used for multiple use cases. We are seeing more and more event trigger model happening on it. So I was talking about one key feature is the AZ copy. Initially, I was touching through. So one interesting functionality that we brought into the AZ copy is the ability to copy data movement from AWS S3. If you see that we also started to build a lot of interoperability tool between different clouds, Amazon being one of the other clouds at this point in time, the large public cloud. So we have, you'd be surprised to know the number of integration points we have with Amazon. For example, this AZ copy is one feature. If you use Azure Data Factory, you'll be seeing that there are, if you're using Azure Kinesis or any other services within AWS, we can actually monitor those services and pull the information into Azure. And Logic App has got a lot of connectors for it. If you use any of the Azure Arc, which is a Kubernetes platform, which is basically think about this like a single pane of glass. You can put in agents in AWS, you can pull the information through. If you're building on AWS, you can use Azure DevOps. The reason I'm bringing that is in the today day and age, it's all called as multi-cloud or multiple cloud. So we are starting to build tool sets that also makes life ask the customer much better streamlined versus you don't need to go and build a separate plugin. So we directly interact with S3. I've seen customers when some events happen in S3, they can pull the information to Azure to process. So the reason I want to mention that is when you try and use AZ copy, you can look for the feature set. You might have some use cases which I don't know now. Maybe you can use that as well. So Azure disks, which is again another Azure disk. Think about Azure disks are basically think about a hardware. It's a physical disk that is available for customers to consume and use. Okay, so Microsoft used to have before managed disks become prevalent. We had I would call unmanaged disks. But that's not there. That's still there, but it's not widely used. Unmanaged disks are basically where a disk would be created in one of those storage stamps. If I think I would have told you, maybe I've spoken about earlier, we have a concept called availability sets. So availability sets are basically, think about individual server clusters that will host your workload. Usually the recommended practice is have multiple availability sets. So that you don't have the issue of one cluster goes down, the other cluster is available to cater. So initially, what might have happened is if you're creating unmanaged disk, particularly for an application, all the disks might live on the same rack. When the particular rack goes down, your entire storage, if the storage is gone, pretty much your compute becomes useless in a lot of ways. You might have issues. So what ended up happening is, I think 4 or 5 years ago, we came up with the idea of, we came up with this managed disk concept. In the managed disks, we use the native high availability feature of Azure so that your disks are also distributed across multiple fault domains and update domains. Anything happening on as a storage stamp is not going to affect you. The reason I'm bringing that is when you're building applications, you have to make sure you select the right type of storage system and then accordingly use that. In this case, the managed disk. So one other key enhancements we're making with these disks is the ability to have this volume of data. So in this case, we have at this point in time, we can go up to 64 terabytes of store, up to 160,000 IOPS, and also 2,000 Mbps per second. These all built for our customers that are basically needing SAP type workloads, HANA type workloads. But on the lower end, you can have a much more smaller disks these days, based on a standard hard disk, which is basically 32 terabytes with 2,000 IOPS and up to 500 Mbps, and use it for backups and things like that. So the key message I want to share is, depending on your workload, depending on your availability or resources, you can choose different types of storage system. This is not only this, there are hundreds and different types of combinations you can do. And also, if you think about things like security, again, you have two types of secure encryption. One is by default, all the Azure storage systems are encrypted at rest by default. You cannot switch it off. On top of that, if you want to do specific things, like if you want to use Windows, you can enable a BitLocker. And if you have Linux, you can do de-encrypt. or if you want to have a third-party tool that can just enter the risk and do that too. So depending on your needs. So today, and also. Sorry, Kadir, everything okay?
Yeah, everything is okay. We can hear you. In between, you went a little bit for a couple of seconds, but now you're okay.
Okay, give me 1 second. I think there is. Can you mute the recording for a few minutes, or let it go because I have some issues here. Let's just 1 second.
Yeah, we will edit it. No issues, no problem.
Okay. Okay, I think we're back on track. So I was talking about the disk portfolio. The last one I want to mention is on the latency wise. These special disks are created purpose built for SAP. A lot of large retailers, at least in Canada and around the world, are moving their SAP systems to Azure. I see multiple different opportunities are moving. A lot of customers have huge ones, multiple different types of SAP workloads. And one of the big challenges still few years ago is the ability to have these type of these systems because of the compute needs and the network needs, as well as the throughput required for SAP is huge, especially if you run in SAP HANA. So at this point in time today, SAP has worked with Microsoft to build number of specific solutions and hardware capabilities and things like that on Azure. So that's one of the use cases which we are seeing significantly increased. And other workload I've seen a lot is SaaS. SaaS used to have two types of products. The SaaS Via is a new product which runs on Azure. It also takes all the capabilities of Azure to the max. The databases like IBM databases and Cassandra. So each of the databases has their own requirement in terms of what they do. We also cater for the needs. So in summary, we don't really, if you have the type of workload, you can choose the right type of storage systems to go for it. And Ultra Disk is again, it's a new type of system which I spoke about earlier. It was again brought in for specific needs from these different types of storage data needs. The SQL Server, most likely in Microsoft SQL Server, you tend to use SQL MI or managed store, but still some customers tend to use, if you're having a third-party application that depends on the SQL Server, you still use it. SAP, NoSQL, data stores, MongoDB, and Cassandra. For those use cases, customers are moving towards a managed service like Cosmos, but still there is appetite for customers to host the entire MongoDB on Azure or Cassandra on Azure. And main thing is one key takeaway for everybody on this scenario is the throughputs are extremely very key for these workloads. Some of the times you can go up to 160,000 IOPS. Also, you can also have massive throughputs too. Again, as we go along, we started to increase the capability to highest possible. This is again a bit older information. Some of the newer disks we are offering or have more storage at the same time higher IOPS. So that area we are investing extremely lot of dollars and cents to give the best class storage systems available. And obviously, the more bigger the disk you have, you also need to make sure the compute is also able to keep up with that. So we have complementary computes to go with the storage systems as well. One of the things is how do you architect your systems for high availability? And also there are three, I think we spoke about the regions have increased substantially. It's not 54, it's close to 60 now. So if you have a single virtual machine, Microsoft is the first one that gave us, if you have a single VM, we give you 3 nines availability. If you have, I think if you have availability sets, we give you 99.95. If you have availability zones, your availability increases up to 4 nines. On top of that, we also give you site recovery and regional pairs. When you have site recovery, meaning is your primary goes down, secondary can come up, and vice versa, right? So depending on how you're deciding it, you have this capabilities out of the box as well. On top of that, we start to give orchestrated failures and recovery. So which means your primary is available on one region and it fails over the secondary. So we also make this process of failure very seamless by making sure there are pieces of software we build is called Azure Site Recovery Services, which also constantly monitors your workloads and health of it and disks and a whole lot. And then it can make the instantaneous flip over between the primary and secondary based on the needs. One key point I want to highlight on these ones are a lot of the one of the question always, how does Microsoft know like the disk is going to fail? So these disk storage systems, the compute generates massive amount of telemetry. So what happens with this telemetry is we collect every single bit of information. It runs through a whole gazillion machine learning logic and things like that. Actually, we can predict when a disk is going to fail much earlier before the actual disk can fail. So because it's all mathematical models, the engineering goes into, we have a lot of supervised and unsupervised learning, which are and also a lot of deep learning models are implemented on top of it, where we can predict failures, we can predict network throughput issues. Because, for example, most customers have this challenge where only at certain peak times, all of a sudden the usage would increase significantly. But if you see in the last 4 or 5 months, nobody predicted this particular spike in the compute and resources. In this case, even though you might have built a model which works on certain times, but unknown spikes also be monitored and captured. So these systems are built fully with AI and ML logic. There's a whole paper on it. If you want, I can share that. We could this lot of predictability machine learning model goes into it, and then we based on it we make a deterministic effort on what might go wrong. As a customer, you won't even notice it because all happens in the backend. So if you find the disk is not healthy, what we start do is we start to copy the data into another disk within the which has got exact same configuration, and move your data and then remove the older disk out of the circulation. As a customer, you won't see that because all happens in the backend. So so there are other few capabilities that are coming into it. So one is we are building a premium SSD disk with write latency reduced to 1 millisecond. This is for different types of machine learning workloads and AI modeling that's used for it. Disk bursting, where you can have ability to see the blob storage, always known to have in the blob storage you would not say how much capacity you want. If you want more, you can store it more, but that was being challenged on the disk side, where also introducing disk burst capabilities. There are certain areas which we are working towards containers, where improvements specifically because persistent volumes on containers are very different way of things. So we are working on the two. Snapshots has been a challenge, where customers want to take a snapshot of the entire disks at any given point in time. We're working on that. Shared disks, for example, today you can have an option where a disk can be shared across multiple virtual machines. This is useful for SharePoint or any type of workflow that needs a shared disk capability. It's available out of the box now. And then last point is, customers always want to keep their own keys. You know what? I like what Microsoft doing on the key wall, but still my security and compliance need says I need to keep my keys on premises. Give me an option. So we have been working on that. So now today you can actually have your own key that can be used to encrypt the disks on top of our own encryption. So these are the features and the capabilities we want to bring that into it. Yep. Again, I was talking to you guys about the compute layer. So the compute and storage go, especially disks, go hand in hand. We have entry-level compute to storage. The last one is the L series, which is specifically built for storage optimized virtual machines. Where, for example, if you take Cassandra, one of the learnings I had is that disks, traditionally we have a disk which you take the backup, the whole lot, at least with databases like Cassandra, where the disks, it's every single, if you have 5, or you have 4 or 8 or 16 type of nodes, each disk will have a subset of the data. It doesn't need to be backed out, technically speaking. That's what I heard. But you can always restore the data at any point in time, because the way that does it, there's a ghost protocol. I think it's used a ghost protocol where every single bit of information is sliced and diced and stored in multiple different disks. So there are certain, we build a special compute called L series. And also we have compute that can be stored for large databases. Yeah, the whole lot goes into, there are premium disks can go up to 80,000 IOPS at this point in time. And also I want to mention some of the series machines have InfiniBand. So InfiniBand is basically uses a special type of drivers from Intel and networking, so that gives you higher throughput, especially if you're building any type of gaming can be used. FPGA, which is called the field programmable gate arrays. So in short, what we do is in your traditional disks or like network cards capabilities, where my understanding is that the network cards are not closely tied in with the compute layer. It has got they physically separated to be in its own space or own area. That how what happens is data has to travel between the network card and the compute layer. It added some latency. So what we end up doing is few years. So Microsoft has been working on the FPGA for a number of years. So the FPGA and also the innovation happens faster space. A lot of these cards have been physically replaced. At least with FPGA, what happens is we are able to start to program the chip itself like a programming model. The innovations can be pushed faster without need to have a change in the entire whole ecosystem. And if you look at the FPGA architecture, it looks like a single chipset, but it has got programmable gate arrays into it. So Microsoft can push new innovations on much rapid pace, like a software development versus the traditional way everything is hardware based. And last one is we started having Cray services on and Azure, and we also started to release quantum model computing on Azure too. So the innovations are happening at massive pace. I just want to share the L series, where these are specifically built for the certain types of databases storages. The bigger one is LAT virtual machine V2. As you can see, the IOPS is 80,000 IOPS and MBs per second is 1,400. So that these are massively huge. I think that brings us to the last part of the session. So I have one pending work. I need to show you some samples. I'll open the floor for any questions. This has been a heavy topic, I know. In terms of we covered blob, we covered the security and also disks, various types of disks that's available. So the whole lot we covered. So I'm opening the floor for questions.
Krishna, there is a question from Nagendra in the chat. He basically is asking, I believe we either can have availability zone or availability set. So how do you decide between these two?
You can have both as well.
Oh, we can have both? Okay.
Yeah.
Okay. Because I was attending that free lecture from Microsoft, right? In that they said only one of it is available to choose when you select. So that's what confused me.
Application architecture plays a major role. So in this case, if you think about when you define the application, right, you can have in such a way that you can have a combination of both. That's not on the technical level, but at application design level, you can do that.
Okay.
So for example, I'll give you a very simple example, right? So let's say availability sets is if you take Canada Central, we're going to have AZs, okay? And Canada East doesn't have AZs. It's got only Canada East doesn't have AZs. It have only availability sets, right? When you design the application, see, I didn't. What happens is you can choose accordingly. In the East, you can use availability sets, and Central you can use availability zones. So maybe when you're in the same data center, maybe you cannot choose them at the same time. But depending on architecture, you can mix and match. Anyway, I was not a part of the session. I'll find out what they mean by it.
Right. So I think that's what, I mean, whatever you said is what it was explained, right? So within a data center, let's say if you have both options available, correct? But you can only choose one, right?
Yes.
So like let's say you have both, right? How do you decide like which one to choose? You are saying like it depends upon architecture, like you choose another one in another place where you have a, let's say, opposite of that, right? If you choose in one data center as the availability zone and then other center as a availability set, something like that, right?
That's a fantastic question. I was actually I'm dealing with the issue now. For example, it's also where you want to make your it's like where you want to make your compromise. Okay, let me explain. So uh, there's a product called HT Insight in Azure. Okay, so that HT Insight does something very interesting. It's got a product called Zookeeper. Okay, the Zookeeper is basically called as it uses a Praxis algorithm to make sure it does the leadership election. So some regions in Canada have 3 fault domains. Some have only 2 for certain types of workloads. So in that case, what happens is based on what is available, the engineering team made a educated compromise. Hey, you know what? If you are deploying this on Canada Central, you have this level of availability. If you're deploying Canada East, because of the way architecture, you have this level of availability, right? So you work with the business and then come up with the understanding. Okay, this is all you can do best on this particular scenario. This is the best you can give. That's where if you have availability zones in Canada, I can give you higher availability, 4 nines availability. Versus if you do deploy in Canada East, you have only 2, like 99.95. So you make your compromise on that, and there is no other way to doing it. So it's business and you where you land it, because you cannot do anything more than that, right?
Right. Thanks.
Other questions? Let me know.
No, it's more of a sharing, Krishna, and validating it with you, right? So we have different types of. If you show your slide that had FPGAs and CPUs, GPUs, right?
Yep.
So we basically have different types of hardware architecture, and VMs are provided to us based on different types of hardware architecture.
Yes.
And we have to choose the VM with the specific hardware architecture based on the product that we are building. As an example, if a product requires a lot of repetitive tasks, for example, like for example, Siri, right? Whenever I say hello, it's a repetitive task, right? Identifying that I have said hello. So those repetitive tasks, if my application is to do, then I choose FPGA, for example, right? VM. And then if it is like a very complex ones, I choose a CPU, right? And if it is a video, for example, GPU is good for video because it does in multiple small chunks, right? So GPU is good for video. So this is just as an information. The question is there any guidance from Microsoft that basically says, okay, what type of application you have to choose, what type of VMs which supports its respective hardware, right? So that's my question.
So so that goes by vendor to vendor. Okay. So I think if you want a faster read write, I would not. That doesn't mean. See, the compute layer, the GPU all layer depends on what sort of compute needs are necessary, right? So compute is a different story. In your case, if you have massive read writes, I might keep everything on my cache layer and do the processing. I tell you where determination is made not by Microsoft. We can give you guidance, but a lot of the determination is done by the application layer. I tell you a very simple example, real world example. If there are people from that worked on the SaaS, there's a old product called SaaS Grid, and the new product called SaaS Wire. In the SaaS Grid world, it's supposed to be living on premises. The disk and network IOPS requirement for SaaS Grid is exponentially higher in terms of the type of network card you have to use, the amount of throughput it requires. It also uses a shared file model where everything has to be available at a couple of gigabits per second, which is impossible to build on cloud. So what SaaS did is, okay, in the cloud world, they came up with a new potential architecture called SaaS Via, which took all the cloud aspects of it and made the processing much more distributed and with the conditions of the cloud. So in this case, for example, for SQL Server, we can give you guidance what sort of IOPS you need, what type of hardware requirements you need, what sort of throughputs you can do. We can definitely give that. If you want to deploy NetScaler from Citrix, we can say, if you want to run a NetScaler, you have to run on these particular type of hardware with this network card. Again, we work with NetScaler and those things. So what we do is, especially if you want to run AutoCAD on Azure, If you want run, Adobe, on Azure. So depending on the product specifications of the vendor, we work with the particular vendor, or the vendor works with us to release the product specifically to Microsoft, and then release stamp an approval onto Azure. For example, if you're running Genesis as an example, right? Genesis would have a certain requirements. The short answer to your question is, depending on the vendor that you want to use, most of the time, most vendors work with Microsoft. We have a specified configuration for that particular vendor. I'll give you a very beautiful example called Pivotal Cloud Foundry. PCF is used by a lot of enterprises. If we go into the PCF configurations, they will tell you, okay, you have to use the DS-V3 machines for all your worker nodes. And if you're using a load balancer, it has to come up with the standard load balancer, not the basic load balancer. And you have to, if you're using IP, you have to use certain set of IPs. So basically, depending on the manufacturer's recommended practice, Microsoft follows, because we can't touch every single application in the world, but anything that Microsoft provides. For example, people used to host Exchange servers on Azure, which was not the best thing. They are now, hopefully they stopped doing it. But there are some customers, they wanted to run the entire Exchange. In that case, we said, no, that's not the right thing. Go to O365. So we give you a strong recommendations on solution services based on the customer's requirement. Sometimes we also say don't do it, but still customer do it. Anyways, that's the thought. Some customers know, they know better than anybody else. They still tend to do it. For example, building up a huge cluster file system. Cluster is fantastic, but do you really need to host it on Azure, on the cloud? Questionable, right?
Yeah, understood. I think it's also depends upon the application that you're doing. Like I said, some example, we had this practical problem, right? That's why I kind of brought up this question. We were trying to do some kind of video quality analysis metrics in one of the projects, right? So we used a CPU, and obviously CPU is not really made for video. Because CPU is, if you look at the CPU architecture, it is used to do complex things. But the video, what video requires, multiple simple processing happen, right? Concurrent simple processing happening, right? So that GPU architecture actually fits that. So then we had to end up choosing GPU architecture to really do the job what we wanted to do, right? So then we had to choose a VM that has a GPU rather than choosing a VM that has a CPU. Then it made sense for us, right? So that was the trigger to kind of ask you this question, Krishna. But I got the answer. Yeah.
No, I think this is a very key question, right? So most of the time when the customers start the cloud journey, they start to think cloud is a lift and shift place where they have anything on-prem, they want to dump into Azure or cloud or AWS. What happens with that scenario is the value of the cloud diminishes and the cost increases significantly because it was not supposed to build on. This is what I want. I've seen applications which cannot able to handle the HA and DR capabilities in Azure. For example, there are applications which can run only in a single core with a certain attributes, and we cannot change it. When customers try to put those applications on Azure, all of a sudden, boom, things go. Because the fault domain is the one where one server goes down, and we have the exact replica on the other fault domain where you can switch it over. These applications have fixed IP. IPs cannot be changed forever in Azure. The IPs are only available till the environment is available to be machines are up and running. If you don't choose a non-static IP, the IP is recycled, right? So yes, this is where I think one of the lessons we have. I'm going to show one of the. It's called the Cloud Architecture Framework, which helps customers and enterprises decide the type of target state environment they should choose on Azure. Versus, we can't just dump everything, like people running SQL servers on Azure, which is not a very smart thing to do at this day and age because we go with the management. So yeah, long story short, there are ways and methodologies. If you're running machine learning models in a CPU or video processing on CPU is useless, you have to go for GPUs. Yes.
Yeah, I mean, especially machine learning that is repetitive, FPGA is better. And I know that 5 years back or something, Microsoft acquired Xilinx or Altera, one of these two, I forgot. And one of the reason was I was reading that article, and they basically was telling that if they have to do some AI related stuff, for one query, probably they need to put, I don't know, 10, 15 servers. Now, if they can embed that logic into FPGA, they were able to do that with the one small chip.
Yep.
Right? So the cost substantially reduces. It's not only the cost of the hardware, right? It's also the cost of the space, power, everything. No, it's a small chip against 10, 15 servers doing the same job, right?
Yep.
So yeah.
And efficient power consumption is also very key, right? When customers look for the cloud, what they don't realize is it's not having the equal copy, but how much power that needs to process is also different. I mean, Azure, we don't charge you power, we charge you a cost, but also a lot of things taken into consideration when they move to the cloud journey. So yeah, hopefully that answers your question, and also the team members.
It answers, too. But I'm looking forward to your future session on that architecture stuff that you mentioned, right? When to choose what, that would be a good one. Yeah.
It's called the Azure Cloud Architecture Framework, and we also have a Azure well-designed architecture. So where we educating customers how to design their applications and solutions for the cloud in the proper fashion. So that's a whole set of series that's available. That's I want to, after this session, I really want to give like a run through it. It's a lot of materials into that as well. So
yeah,
I think we're coming to the we're coming to the top of the hour. So I would
we can close the call. But thanks a lot, Krishna. In spite of the other sessions, it's a long day for you, but thanks a lot. Still, we see the same energy, same passion to help us to learn. Thanks a lot for that.
Sure.
Yeah, we can close the session. Just a one thought here for those who are attending today. If you have not registered for June 20th meetup, which is on the cybersecurity, please remember to go to Eventbrite and register yourself right away after this session. Over to you, Krishna, for the final closing, and we can close this.
So thanks for all the support. I know coming on a nice day like this and listening to sort of fun for me, but technical stuff is very but thanks for your time and dedication. So Kadir, the one session I present to India is for AI and ML and how industries are going to be affected by it. So maybe if anybody's interested on how to know AI and ML is impacting industries, we have very good panel speakers. Saad is one. I had a data scientist from Microsoft that works extensively on solving real world problems. I'm more than happy to share that session. Also share the slide deck to you guys. That could be a very good session. I enjoyed it totally. About 650 people attended the session today morning.
Yes, please send it across. And you know that after the cloud, we are starting on AI ML. So if you could bring them to help us with this. I think Shad is going to join you in AIML, if I'm not wrong, right?
He's my co-presenter as well. He was my co-presenter today.
Oh, okay. So you're going to work with him for our AIML track as well, right?
Absolutely, yes.
Yeah. Please make sure that, please send them beforehand. We'll be happy to learn them beforehand. But we are also looking forward to you and Shad train us after the cloud on AI and ML journey.
Thank you. Thank you, guys. Still the number of people there, but really appreciate all the time and effort that you guys are spending. Really appreciate it. Feel free to ask any questions. I have some pending homework to do, but thank you. Thank you all. Have a fantastic week ahead.
Thank you, Krishna. Take care. Bye-bye. Everyone, take care. Bye-bye.
Thanks.